Listen up, rookie. We are skipping the fluff today. You're looking at a dedicated explainer for your Module 7 B1 test prep. Specifically, we're going to quickly cover questions 17, 30, 46, 57, 72, 76, 159, 160, 163, 170, 174, 188, 220, 239, 254, 258, 270, 273, 279, 298, 299, 311, 338, and 356. We're diving straight into the exact scenarios you're going to face on your exam, and honestly, more importantly, the exact situations you'll face on my hangar floor.
I want you to anchor these facts in your mind, okay? Because knowing the why behind the tool, well, that's exactly what separates a true mechanic from a simple parts changer. I fully expect you to be the former. We're going to drill this aviation logic into your head right now. So let's get to work. All right, Section 1, Electrical and Avionics Testing. Step right up to the avionics bench and pay close attention here. Frying a circuit on this bench? Yeah, that costs more than your annual salary. You need to memorize these rules right now. If you're using a voltmeter, you always connect it across a component. Simple enough, right? But with an ohmmeter, you absolutely must kill the aircraft power and isolate the circuit component you're testing. Why? Well, because an ohmmeter actually provides its own voltage to measure resistance. So if the aircraft power is on, boom, you blow the meter. Next up, a mega ohm meter pumps out 500 volts or more, specifically to test your insulation resistance. It finds exactly where those wires are leaking power. And finally, notice that voltage drops are measured in millivolts. That's MV. We use those tiny, tiny measurements to catch bad, corroded grounds long before they take down a whole system. Never forget that omega symbol. Ohms are your standard unit of resistance measurement. And, when you're looking at a shiny new multimeter's resolution, that specific term tells you exactly how small of a measurement that meter can actually indicate. Obviously, better resolution means you can see much finer details in the circuit. Now, when you're checking heavy feeder lines and you really don't want to break the circuit, you're going to grab the current clamp meter to measure the current magnitude. It's simple, it's safe. But if you're testing radios, your directional wattmeter must sit right between the transmitter and the antenna. No exceptions. That is literally the only way it can accurately read the power going out and the power reflecting back. Moving right along, Section 2, Precision Measuring Instruments. Let's step away from the wires and head over to the tool crib. This is the place where close enough gets people hurt, and we rely heavily on absolute mathematical precision. So why do we bother with precision measuring instruments? Look, if you're just guessing instead of measuring, you are guessing with people's lives. We use these instruments for one very specific reason: to measure dimensions with great accuracy. Seriously, there is zero room for error on a turbine shaft. Knowing which tool does what is completely non-negotiable. Your vernier caliper is basically your multi-tool here. It handles inside dimensions, outside dimensions, and height measurements. But let's say you need to find out if a spinning shaft is out of round or eccentric. How do you do it? Well, you set that shaft on V-blocks to check its ovality, and then you run a dial test indicator, or DTI, right over it. The DTI is going to indicate those microscopic, tiny differences in size as the shaft turns. Oh, and don't forget your snap gauges. You'll find those in the crib as both adjustable and non-adjustable types. You just need to pick the right one for your specific tolerance limit. All right, Section 3 is hand tools and shop safety. Let's hit the fabrication bench next. This is where shop safety and honestly just picking the right chunk of steel for the job is absolutely mandatory. Let's talk about a really common rookie mistake. You have a bolt to fasten. You could choose an open end wrench, a box end wrench, or a socket. Always, and I mean always, reach for the socket first. A socket grips all sides of the fastener completely evenly, which vastly reduces the chance you're going to strip the head compared to an open end wrench. Treat the aircraft hardware with respect, all right? You need to follow these hangar survival rules, or honestly just pack up your box. Power tools? I want all protective guards and fences securely in place before you even think about touching the trigger. If you're using a file, never, ever stab your palm by going handleless, and make sure you keep those teeth clean with a scratch guard. What about working deep in a wheel well where direct access is impossible with straight tools? Well, that is exactly where your pneumatic angle drills are going to save the day. And listen to me very carefully on this last one. When calibrating your wire crimping tools, do not crimp the go/no-go gauge. Let it slide through, or you're going to be buying a new, very expensive calibration tool out of your own pocket. Now, I need you to memorize these two letters. HB. When you're marking out cuts on aluminum sheet metal, you only ever use a pencil with HB hardness. Why? Because using ink, felt pens, or metal scribes will actually create stress risers or chemical reactions that cause the metal to literally crack under flight loads. Use an HB pencil, nothing else. Okay, last section. Aviation lubrication in grease. Go ahead, wipe off your hands, and step over to the lube station with me. We're going to talk about grease. So, what is the absolute first thing you check before using a grease gun on an aircraft bearing? Before you even think about squeezing that trigger, what must you do? You do not just start pumping. You have to ensure that the grease gun is refilled with the exact correct type of grease for that specific component. Mixing incompatible aviation greases, it turns them into a useless, soapy mess. Check the manual, then check the gun. Now, even with grease guns sitting right there, we often pack bearings by hand. Why is that? Because manual grease application forces you to actively feel the bearing. It critically allows for the physical inspection of the rollers and the cage in conjunction with relubrication. You can actually feel a rough spot with your palm that a grease gun would just push right past. Let's see how this builds your diagnostic skills. One of the main characteristics of aviation grease is that it's specifically formulated to remain chemically stable when it gets heated. It really shouldn't break down. So if you open up a bearing housing and that grease has suddenly turned a dark, discolored black, well, that dark coloring directly indicates the presence of metallic particles. The bearing is actively chewing itself apart. So, are you ready? You now have the exact test answers you need for Module 7, but way more importantly, you have the hanger logic to actually back them up. Study hard, review this explainer, and respect your tools. Because when it's 3 a.m., a flight is delayed, and a warning light is flashing, are you going to be a parts changer or are you going to be a mechanic?